In this video, I want to walk through finding the integral for the inverse sine of x with respect to x, and we're going to do so using integration by parts, and so I've written that formula over here on the right side. So to use integration by parts, it looks like we need to find a value for u and a value for dv. So we're going to take this integrand and split them up into those two parts. Okay, so I'll say u equals, and then of course we're going to differentiate that, so I'll go ahead and put my du there. And similarly, I need a dv, so above that I'll just put the v, so we have this nice little pattern. So for my u, let's go ahead and use the inverse sine of x. And for my dv, let's just go ahead and use dx. Okay, so both of those parts are being used. So to go from u to du, I'm going to differentiate both sides here. So the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. And of course, I'll throw the dx in there with it as well. And now to go from dv up to v, we need to integrate both sides. And the integral of just dx is, well, just x. Okay, so I have all four parts here that I need, and that will work nicely in my formula. So it says, using integration by parts, I'm going to have u times v. So I'm going to take this u and this v and multiply them together. So this integral ultimately will be x times the inverse sine of x. Okay, that's the uv, minus the integral of v du. So v is going to be x, and then my du is this expression here. So I'm going to multiply these two things together. Let's just go ahead and put that x up there on top where that 1 was, and that's multiplying there. And so it looks like this with our dx. Okay, so here's what we get for the integral of the inverse sine of x with respect to x. The problem is, of course, we have another integral, and that's okay. That's part of integration by parts formula. So how can we now integrate this part? Well, it looks like we can use a really nice, straightforward, just u substitution. Okay, so I'll kind of push over here a little. So let's say u equals 1 minus x squared, and that's just the stuff under the radical here. So when we differentiate both sides, du will equal, well, negative 2x dx. And then my dx will equal, we can divide both sides by negative 2x. So I'll have du over that negative 2x. Okay? So now let's go ahead and rewrite this integral using my u terms that I have. And I'm going to ignore this negative for a second, and I'll come back to it here afterwards. So we have now, for this integral, the integral of, and so let's go ahead and put the x right there over the square root of, well, u. And then the dx, let's go ahead and substitute this. So we have du over negative 2x. Well, okay, well, I notice I have some d's or some du's and some u's and some x's, but it's nice because these x's actually end up canceling. So let's take this negative out front. So we have the opposite of the integral of 1 over 2 times the square root of u du. Well, okay, well this is not so bad. This is actually a fairly straightforward integral, because let me show you something. There's a nice rule that we have. So the derivative of the square root of u equals, well, u prime over twice the square root of u. Okay, so that means that I can relate this back to this, and I know that the integral is actually just going to be the opposite of the square root of u. And then, of course, you can put your plus c in there now if you like, which that piece becomes, when I replace the u back with my 1 minus x squared, is that right there. Okay, so this little part, this negative square root of 1 minus x squared, and then of course your plus c, actually was this integral part right there. And so here's where this negative, I said we'd come back to it, and this negative will actually cancel one another out. Okay, so my overall integral now, let's start with this first piece. So the x times the inverse sine of x, the negative and the negative cancel to make it positive. And then I'm just going to have the square root of 1 minus x squared plus c. Okay? And that's going to be my integral for the inverse sine of x. And what would be nice to do, let's go ahead and differentiate this just kind of to make sure we've done it correctly. So it looks like I have the product rule here and kind of the chain rule here. So let's go ahead and use the product rule first. The derivative of the first, which the derivative of x is just 1, times the second, so inverse sine of x, plus the first times the derivative of the second, so 1 over 1 minus x squared, plus, and then it's the derivative using the chain rule, but we kind of wrote this rule up here already. So the derivative of the square root of some function is u prime over 2 times the square root of u. So it's going to be u prime, so negative 2x over twice the square root of that 1 minus x squared. And of course, when I differentiate the c, it just goes away. So let's kind of clean this up a little bit. And so here is our derivative. So we have the inverse sine of x. And a couple things here. It looks like these 2's will cancel, which is nice. And this term here looks like a positive x over the square root of 1 minus x squared. And this one looks like a negative x over the square root of 1 minus x squared. Well, that is really good because those two critters end up canceling, and we are left with just the inverse sine of x. So we know we took the integral correctly because when we went back through and differentiated, we did get our initial integrand. So using integration by parts, we saw that the integral of the inverse sine of x with respect to x is going to be this expression, x times the inverse sine of x plus the square root of 1 minus x squared, and of course plus c.